In this video, we are going to extend our thinking about polygons to include quadrilaterals. So the first thing we should do is actually understand what a quadrilateral is. And if you recognize the word quad, you'll know that it means four. And as we talked about before, the word lateral means side. So what we really have here is any four-sided shape. And so we could draw some examples of quadrilaterals really quickly here. Something that you might recognize as a rectangle, maybe something else like a kite, or just a random four-sided shape such as this thing here. I have no idea what it is. So any shape with four sides is considered a quadrilateral. But like anything, we can actually give some more specific names to different types of quadrilaterals. And there's a whole bunch of different ones, but we're going to focus on 5 different quadrilaterals in particular. And all of these exist because of certain differences between them. So the first quadrilateral that we're going to look at is a trapezoid. A trapezoid is basically a quadrilateral that has one pair of parallel sides. So if you look here, this top line here and this bottom line here, they are parallel, meaning that they will never ever meet. So a trapezoid has one pair of parallel sides, and that little symbol here means parallel. So one pair of parallel sides. So this is our first sort of major type of quadrilateral. Our second major type of quadrilateral is a parallelogram. And a parallelogram is a quadrilateral that has 2 pairs of parallel sides. And so you can see here that the top and the bottom are parallel, and then the 2 slanted sides are also parallel. And those little arrows mean that they are parallel to one another. Just like we use those little tick marks for length and those little angle marks for angles, those are meaning that they're parallel. And so these have 2 pairs of parallel sides. And so most quadrilaterals end up most types of quadrilaterals that we're going to look at end up as being either a trapezoid or a parallelogram. Now, where this gets interesting is that there are actually special types of parallelograms. There's also special types of trapezoids, but we're not going to look at those. But we will look at some of the special types of parallelograms. And so the first one that we're going to look at here talks about the specific angles of the parallelograms. And this is what is known as a rectangle. So you recognize a rectangle from before, of course, but what makes a rectangle special is a rectangle is a parallelogram that has all right angles. All of the angles of a rectangle are 90 degrees. But notice it's also a parallelogram because it meets the condition of having 2 pairs of parallel sides. So you can see that the top and the bottom are parallel, and the left and the right are parallel. So it is a parallelogram, but it's a special parallelogram with all right angles, which makes it. There's another type of special parallelogram that focuses on the length of the sides. And this is what is known as a rhombus. And so a rhombus is a special parallelogram that has all congruent sides. And so you can see from the little tick marks here that yes, all 1, 2, 3, 4 sides are congruent, but also, just like the rectangle and just like the parallelogram, all of the sides are, and as you can also see, just like the rectangle and the parallelogram, it has 2 pairs of parallel sides. So the top and the bottom are parallel, and the left and the right are parallel. So a rhombus is also a parallelogram. The final parallelogram we're going to look at is the most special of parallelograms because it combines features of all the others, and that of course is a square. What makes a square special is the fact that it is a sort of a combination rectangle and rhombus. So you can see that it has all the right angles, just like a rectangle does, but it also has all equal sides, just like a rhombus does. So the square is the most special of quadrilaterals. Now, just like we did with triangles, we can also find the value of the missing angle in a quadrilateral. And there's a couple of different ways to do this depending on what type of quadrilateral you're working with. But we'll look at the way that kind of is the most basic and works with all of them. Now, the first thing to kind of keep in mind is that quadrilaterals are connected to triangles. And if you remember, the sum of the angles in a triangle is 180 degrees. Something that we can do is we can actually divide a quadrilateral into triangles. And so I'll do that by just kind of drawing a line here. It's not the best line, but you can kind of see that we've got now two different triangles in the quadrilateral. What that really tells us is that the sum of the angles of the quadrilateral is twice as big as a triangle. So 180 times 2 equals 360. So the sum of the angles of every quadrilateral is 360 degrees. So we're going to use that knowledge to help us find the value of the missing angle here. So what I really know is that angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360 degrees. So let's throw some numbers in here. 50 plus 130 plus 50 plus n equals 360. I'll do some combining of like terms. 230 plus n equals 360. And we'll minus 230 from both sides. And we get n equals 130. So we can quickly kind of write that in there. N is 130 degrees. And if you notice, you'll notice that that's the same as the other angle that was down here. And I'll let you kind of think about why that might be the case.